Hello. So now we've talked about kinetic energy, the ability of an object to do work, to push or pull on some other object for some distance, solely due to the fact that it's in motion. So for example, this ball here, if it's moving, can push or pull on some other object for a distance when it crashes into it. When it crashes into it, there's a capacity for a push or a pull there, a force for some distance. So that means that a ball in motion has energy. Now, there was another type of energy discussed in our introduction, that of potential energy. If you'll recall from the introduction again, potential energy is the capability to do work, to apply a force for a distance due to the relative positions of different objects within a system. So a good example of that is gravitational potential energy. So here I've got a ball with a little bit of extra weight on it. And this ball could do work. It could exert a force for a distance if I were to let it go. If I were to let it go, it would fall, right? And that is exerting a force for a distance on this other ball, causing it to rise. Yeah, via the rope, but still fundamentally, that force is ultimately coming from this ball here. So this ball, having the capacity to exert a force for a distance, means that it has energy. Now, the ball's not moving, well, except for, the wiggling of my hand here. So it's not kinetic energy, it's potential energy. The energy comes from the relative positions of this ball and the earth I'm standing on, which means that there's a relatively important point here. Potential energy requires a system. You can't have a potential energy of just the ball. That doesn't have any potential energy. Take this ball, put it way, way out in space, away from all the gravity you can think of, and it wouldn't be able to do work anymore. It wouldn't be able to push on something for some distance. It's only the relative positions of the ball and the earth that cause potential energy to exist. So that's the first key point, is that potential energy requires a system. You have to take two to tango. So you need at least two objects to make potential energy work, okay? And also, the second key point is that the potential energy comes from the relative positions of those two objects. So in this case, again, the ball and the earth. And so there we can see the work being done. Now, what quantities does potential energy depend on? Well, clearly it depends on the height, right? If the ball is not as high, then it can't lift the other ball as far. The distance over which the force can be applied is not as much. So gravity is going to depend on height. Gravitational potential energy is going to depend on height. What else might it depend on? Well, we can actually see another thing it depends on here in this little demo. It's going to depend on the mass of the object. This ball, with its extra little weight, has more potential energy at a given height than the other one. So if I were to put them at the same height, like so, the heavier one has, well, now it's even worse, has more potential energy. This ball, with its associated little spring weight, has more potential energy than this little pin. Even though they're at the same height, this one has more capacity to push for a distance. The fact that we can again see when we just sort of let it go. So that's two factors. What might be the third factor on which gravitational potential energy depends? Well, if we think about it a little bit, would the gravitational potential energy of this object be the same on the moon as it is on Earth? That seems unlikely. I mean, we know that the gravity on the moon is much, much smaller than the gravity on Earth. A fact we can see here with the little astronauts bouncing on the moon. So this is a video of the Apollo astronauts on the moon, and you can see they're bouncing because of the low gravity. So it seems logical to assume that it would also depend upon the gravitational pull of the planet that you're near. And you'd be right. So in short, gravitational potential energy depends upon three key things: the height above the ground, more height, more gravitational potential energy. The mass of the object, more mass, more gravitational potential energy. And the planet you're standing on. The more gravitational pull a planet has, the more potential energy an object will have at a given height. Combine this with the fundamental fact that you need two to tango, so to speak. You need two objects, and you have a pretty good grasp of what gravitational potential energy is. This concludes this video.